Hey everybody, my name is Heather Bryan and I am the lead educator for Ohio Corn and Wheat's program called Feed the World. And we're really excited to be here today up at Stone Lab on South Bass Island. But before we get started, I want to make sure that we share some housekeeping notes so you'll know how to interact with us here today. If you're joining us on Zoom, you'll note that the chat is turned off today. Please use the Q&A button at the bottom of your Zoom screen to ask us questions. We'll try to answer as many as we can. If you're watching on YouTube, please note that the live chat is also turned off. If you're watching on Facebook, feel free to ask your questions in the comments section. And if you're on YouTube or Facebook and you want to join us via Zoom, you can go back to your confirmation or reminder emails and click on the link to join us in Zoom instead. So let's thank our sponsors today for our programming: Ohio Corn and Wheat and Feed the World, and The Ohio State University at the Stone Laboratory. You'll also be able to locate our previous virtual field trips as well as this one on ohiocorneducation.org, which I'll put in the chat for you in just a moment. So as we get started off today, I want to introduce you to Dr. Brian Alford. So how are you doing, Brian? Good.
Doing great.
Good. So Dr. Alford is the Assistant Director of Stone Laboratory here at South Bass Island in Put-in-Bay. He helps to oversee the implementation of the programming and the research that is done here at Stone Lab. So Dr. Alford, we are so excited to be up here with you today. This is kind of a once-in-a-lifetime experience getting to come up here at Stone Lab. Could you help us understand a little bit about your background and your career pathway that helped you to come to Stone Laboratory?
Absolutely, Heather. I've always been fascinated by everything about the water. I grew up near the water. I'm originally from Mississippi, so the opposite coast from here. I grew up along the Mississippi River and the Mississippi Gulf Coast. I've always been fascinated by aquatic wildlife. I got my undergraduate degree in biology and then a master's in environmental sciences, where I studied fish predation on aquatic insects. And then I went on to get my PhD, studying how fish and aquatic insects can be used to assess water quality in streams. After that, I started working at a government agency. I was a lead researcher for the Louisiana Department of Wildlife and Fisheries in Baton Rouge. I worked on everything from streams and lakes to even marine ecosystems, even working on aspects of the Deepwater Horizon oil spill disaster there. Following that, I spent 6 years as an assistant professor of fisheries at the University of Tennessee in Knoxville, where I got to spend a lot of time studying the impacts of land use and disturbance on our watersheds on fishes and aquatic invertebrates in the southern Appalachian Mountains area where the Smoky Mountains are. And then for the past 3 years, I've been the assistant director here up at Stone Lab. I'm up here on Lake Erie. A new pathway for me, but I'm excited to be here and excited to be part of this program.
It sounds like over your career pathway, you've slowly continued to move north. So I think that this must be the place that you want to be. It sounds like you have quite a good depth and history of science and research that has brought you here. We're really thrilled to have you be a part of our programming here with us today. I see that we are looking at some drone footage of Gibraltar Island as well as South Bass Island. And so perhaps you could give our students just a little history about the Stone Laboratory and how it is associated with Ohio State and some of the work that you do up here.
Absolutely. So Stone Laboratory is the oldest and first biological field station in the country, believe it or not. We were originally located in Sandusky, Ohio, where we were called the Lake Laboratory in 1895. And then around 1908, we moved over here to South Bass Island to the building behind me, which is our research lab. Then in 1925, there was a board of trustees member by the name of Julius Stone. He worked for the Ohio State University. He bought Gibraltar Island, which Kevin is pointing out to us right now. This is a 6.5 acre island just to the north of the town or the village of Put-in-Bay. Ohio State has owned that island since 1925 when Julius Stone bought it. He immediately deeded it over to the university and asked that it be only used for research and education of all things Lake Erie. So it has been a field station for us to study Lake Erie since 1925. We have education programs going on there right now, as a matter of fact. We have dorms where students can stay with us. We have a dining hall that we feed our students at, several cottages for our staff, and then a 3-story classroom building where we can do hands-on education programming in Lake Erie. So we've had this 6.5-acre island, like I said, since 1925. And we're very excited to be part of this community and here on Lake Erie.
That sounds fantastic. I see that there is actually even a castle out there on Gibraltar Island, so that's pretty cool too. But
Yeah,
you are, go ahead, I'm sorry.
yeah, I was just going to say that castle was part of the island when we bought it. That is called J. Cook's Castle, and we do offer tours of our island and of that castle, so the public can come out to see our island on occasion. And that was built in 1864. It was used as a men's dormitory, and now it's used for collecting data on meteorological and wildlife data. So we actually have sensors up on the castle right now it's being used for science.
That's fantastic. I think that's cool how you're not just out in the water quality, but you're doing both ambient, weather
Mhm.
research as well as other. I know that you also do some research up there with herps. Is that correct?
That is correct. So the Lake Erie water snake is a species of snake that is only found on the Lake Erie Islands here in Ohio and parts of Canada. For the past 20 years, we've had researchers here studying the population trajectory of that species. Fortunately, in 2011, it was able to be taken off of the Endangered Species Act, so it's no longer federally endangered, although it is state protected. We continue to study snakes to this day, and we do quite a lot of outreach with a lot of school kids with our captive herpetology colony. That just means we keep snakes and reptiles and amphibians for the purposes of education. But yes, we continue to research wildlife, and more recently, we're getting into other types of wildlife like bats and other types of things.
Well, that's fantastic. I know that part of the purpose of Stone Lab is to do research up there, but I also note that I saw on the sign that it said to educate as well as to give outreach to citizens and the research there. So tell us a little bit more about some of the science that is done. So if we were a student, so if we were a class of
Mhm.
students and we wanted to come up with Stone Lab, I know that you offer something called a science cruise. So what are some of those educational possibilities for students in the middle school and high school setting?
Sure. So every fall and spring, we offer what we call Lake Erie science field trips to 5th through 12th graders. And in some cases, we offer those to even college classes. Uh, but we offer a 2-hour science cruise. This is one of our vessels over here to my left. This is the Gibraltar 3, one of the vessels that we use to take these school groups out on the lake to learn about the lake. We teach them all about water quality in the lake. We teach them about the fish in the lake. We actually have the students do a fish trawl, which you'll see here later. And then the students get to collect plankton samples and aquatic invertebrate samples. But the neat thing about our program is they don't just take them and let them go. They actually will take those samples back to our lab on Gibraltar Island, and then they will get to look at them under microscopes to identify them, to learn about how they impact water quality. And they'll even get to dissect fish. One of the more popular programs we have is where the fish that they catch on the trawl, they actually will take it back to the lab, dissect it, look at all the heart and the stomach, and learn all about fish and how they live here in Lake Erie. Not only do we have that 2-hour science cruise, we offer field trips in geology and ornithology, which is the study of birds. If you come here, you can do a bird walk on Gibraltar Island and learn about the different types of birds that migrate through our area. We have programs on climate change and herpetology. We have, like I said, we have a captive herp colony where students can come up and actually hold snakes and learn more about them and their ecology. So we offer quite an array of science field trips for teachers and classes that want to come up here and spend the day or even 2 days with us. Like I said, you can actually spend the night with us on our island, and we'll feed you and do some educational program for a couple of days.
That's really an awesome outreach opportunity for students. So if you are out there, I would definitely see if you could take advantage of that for sure.
Yeah,
What a great way to get hands-on science. I love the
yeah,
opportunity of being able to catch those fish and bring them back in and to do research on them immediately. That's fantastic.
absolutely.
So
And
go ahead.
yeah, I was just going to also talk about our education programming in the summer for just a bit. We do offer college level courses through OSU, and high school students, advanced high school juniors and seniors can be part of our introductory aquatic ecology programs, our classes, and get college credit through OSU. So in the summertime, you can take 1 week, 4 week, or 6 week courses and get college credit.
That's fantastic. So getting back to some of the college classes and some of
Mhm.
those opportunities that are there, why is it important for us as citizens and as universities to research water quality in Lake Erie? And we did a little history about Gibraltar Island
Mhm.
before, but how has water quality kind of changed over time? So we have a question here from Miss Rebecca Scott from Field Local Schools. She would like to know how water quality has changed over time, not just in the past 5 or 10 years, but
Mhm.
maybe in the course of Gibraltar Island, and then what are some of those current changes? So I'll ask a second
Sure.
question again in a moment, but about agricultural impact. So give us a
Okay.
little bit about the change of the lake quality over time.
Well, sure. Well, we really started focusing in on water quality in the lake when things were not so good. So back in the 50s and 60s, in the 50s and 60s, there was a lot of chemical pollution from industrial factories, and there was wastewater treatment that was not being treated. So we had raw sewage coming into the lake, and these created algal blooms, which could be toxic. But not only that, some parts of the rivers that feed the lake, like the Cuyahoga River, would catch on fire because there was so much pollution in the water. And with the passage of the Clean Water Act in 1972, many of those sources of pollutants were cut off. And so the lake has dramatically increased and improved in water quality in terms of the types of chemical pollutants that are in the lake. It increased dramatically up through the early 2000s. But then starting in the early 2000s, we started to see more harmful algal blooms again. These are types of algae called cyanobacteria that can produce toxins, and these toxins can be fatal to some small animals. They can cause liver and kidney damage in humans. So they really started in the early 2000s, and those have been trending towards an increase ever since then. However, other types of chemical pollutants that had been an issue in the 60s and 50s, uh, we don't really hear about those anymore. So overall, the lake is doing much, much better than it had been in the 50s and 60s. We just need to sort of be able to minimize the impacts of those harmful algal blooms these days.
So it sounds like we've gone from having heavy toxins from like an industry base to
Hmm.
more clean water, and then as we are continuing to produce food with that clean water and the sunlight that comes into the lake, we are seeing a growth of another kind of an organism called cyanobacteria, as well as other
Yeah.
algae. But cyanobacteria specifically is toxic, correct? So it can create the toxins that can be harmful.
Yeah,
We have some
exactly.
yeah, so we have a question here, which I think is really great from Kevin Surratt from Bolton High School. Here at the Ohio State University on South Bass Island, you guys are doing great work to help with research, but what are other states and provinces doing that are associated with the Great Lakes and the watersheds to the Great Lakes doing? And do you have any partnerships with other organizations?
Oh, absolutely. That's a great question. And we partner with other Ohio universities. We partner with Canadian jurisdictions. We partner with out-of-state universities and government agencies and nonprofit organizations. So this is not just an Ohio State thing. It's not a state of Ohio thing. This is certainly a Great Lakes issue. And it's certainly being attacked on all fronts by a lot of different institutions, that is for sure.
Good. So it sounds like everyone within our community is really coming together to help improve the water quality. If a student were to come up and go on your science cruise, I know that you'll help to demonstrate a few things that will happen on the science cruises today. But what are the importance of things like that ambient weather collection or a Secchi disc, for example? I know that you can demonstrate here in a
Hmm.
moment. to some of this so they can help to understand what each test might help you to do as you gather research to kind of come to some
Sure.
consensus on
Yeah,
water quality.
weather and climate will certainly be a factor in how intense an algal bloom can be. For example, we do collect data on water temperature and wind direction because those, just to call out those two things have a direct influence on how intense a harmful algal bloom will be. Typically, the warmer the water, the more productive that microcystis cyanobacteria is, and also the wind direction can change where a harmful algal bloom is going to be at any one point in time in the lake. So all those environmental data that are collected, we need to keep track of so we can identify if there's any sort of correlation or patterns that exist with how intense the blooms are, where they are, and potentially how much toxicity they are producing.
Okay, that's fantastic. So I think that as we move over to the pier, you're going to start to show us some of those stuff. But as we're moving, and perhaps you can answer a few questions from some
Sure.
teachers, I'm going to blend these two together. But from Ms. Callahan, she would like to know where does most water pollution come from? So since we are kind of getting away from more industrial pollution, it sounds like some of that pollution that is coming from land use. Could you help students to understand when you say the word pollution, what really are you referring to?
Well, and specifically in the case of when we're talking about harmful algal blooms, which is the primary issue these days, we're talking about nutrient runoff. That's what we call non-point source pollution. So this would be when phosphorus and nitrogen run off of landscapes. They enter into a roadside ditch, for example, then that ditch that water gets carried into a river, and then that river carries the nutrients into the lake. So the primary source of nutrients that affect our harmful algal blooms these days is from phosphorus and nitrogen that's running off of the landscape, primarily from agricultural landscapes, but not entirely. Upwards of 9% of the phosphorus and nitrogen that comes into the lake comes from point sources like pipes that are entering into the lake, but also there's internal sources of nutrients that contribute to harmful algal blooms. There's about 1 to 2% of the phosphorus that ends up into harmful algal blooms. So when the lake turns over and the mud kicks up, the phosphorus that's bound to that mud will be released and available to the algae. So it's not just one source where these nutrient pollutants, if you will, are coming from, but it's multiple sources. But by and large, it's mostly from agricultural landscapes, at least in Ohio.
Certainly. So I have a couple of quick, easy questions for us. Ms. Schrock would like to know, right now we're kind of more in the western basin, so we're over towards the western side of Lake Erie, which happens to be the shallowest zone of Lake Erie. About what is the average depth of water around South Bass Island? So, can give us an idea of what depth we're talking about here.
Sure. Where I'm standing right now is about 10 feet, but on average, the western basin of Lake Erie is about 25 feet on average, and that's typically where our students are taken, is to about a depth of 20 to 25 feet when they go on a science cruise. So we're a pretty shallow lake, at least this area of the lake, and so that helps contribute to the harmful algae issue. Because Lake Erie is the most southerly of the Great Lakes. So being southerly, it's also the warmest. So algae is going to be more productive just by that very nature. And then also we're shallow here. So there's a lot more mixing of the nutrients. Unlike Lake Superior, which is very deep and very clear, it has very low amounts of nutrients and very low amounts of algae. So just by the natural topography of Lake Erie makes it more susceptible to high amounts of algae production.
That makes sense. We have a kind of a shift in questions here I would like to ask. We have two questions. One's from Miss Meeks and one's from Mr. Jostable at Fort Jennings High School. First, what is the biggest invasives that you see in the lake? And then second question, what species of fish suffers the most from cyanobacteria or other levels in the lake?
Since we're on cyanobacteria, I'll answer that one first.
Sure.
Uh, right now, there's not much evidence to suggest that the toxicity of the cyanobacteria is impacting actual fish, like the fish that we eat. If you come to Ohio, you're going to be eating perch sandwiches and walleye sandwiches. Those are still very popular here, and there's really nothing to worry about with regard to toxicity of those fish. The way that the harmful algae can indirectly impact them is that harmful algae, if big blooms are produced, when they die, the bacteria and the fungi that break that algae down consume oxygen in the water that had once been made by the algae. And when they consume that oxygen, there can be what's called a hypoxic zone at the bottom of the lake. Generally, that's in the central and eastern part of Lake Erie. And after a storm, if that hypoxic zone on the bottom of the lake turns over, which is devoid of oxygen, all of a sudden that low amount of oxygen is distributed throughout the rest of the lake. And if fish are caught in that, there can be pretty substantial fish kills. So there can be fish kills indirectly related to cyanobacteria blooms, but it's not directly related to that toxicity.
Okay.
As far as
No,
and
I
as
was just
far
going to
as
say, you look like you're about to do the Secchi test, and so I know I can bring that invasive question back to you in a moment.
Okay.
If you want to go ahead and do that Secchi test and explain to students
Sure.
what you're doing. Sure.
So this is one of the oldest ways of assessing one part of water quality. This is called a Secchi test, named for an Italian scientist with the last name Secchi. This was invented all the way back into the 1600s, I believe. And this is used all over the Great Lakes. You can actually download data all over the Great Lakes of Secchi disc depths. And what this does is it tells us how transparent the water is. If you have really big, thick cyanobacteria blooms, you're not going to be able to see very far into the water. If you don't have very thick blooms like we have today, right now, it's a very mild amount of bloom, I would say. It's very little amount of microcystis. The water's much clearer. So we should be able to see this disc at much farther depths if the water quality is good. So what I'm going to do is show you how this works. I'm going to lower this disc down, and the point where I can no longer see the black and white triangles is the point where we take our Secchi disc depth. Now, one other thing that we can calculate from this is what's called the photic zone. So the photic zone is the layer or the depth at which 99% of all algae, the good algae too, not just cyanobacteria, but the point at which 99% of algae can conduct photosynthesis. So that's another reason for conducting one of these tests. And so what I'm going to do is get a Secchi disc depth first. I'm just going to lower this down right off the pier. And the point at which I can no longer see it is going to be our depth. I'm actually going to lower it to where I can't see it, and then raise it back up again a little bit so I can see it again, and then raise it back down. So right about there is where I can no longer see it. And so I'm just going to grab the point at which I can't see it, and then I just take a trusty old meter stick, and then I can measure that depth. And for right now, I am about right at 6 feet. So my Secchi disc depth is 6 feet. Now, what I can do, I can make a rough approximation of the photic zone depth by multiplying that Secchi disc depth by 3. So 6 times 3 is 18. Therefore, the depth at which 99% of algae are conducting photosynthesis is at 18 feet. Okay?
Yeah, that's really cool.
So
So
that's
right
one
now,
way. Yeah.
right now in Lake Erie, if the water quality transparency is similar as it is up to your dock there, or the pier, forgive me, it sounds like photosynthesis is occurring, just to summarize here, around 18 feet in depth.
Yeah, about 99% of all the algae, including the good algae, are able to capture that sunlight at least 18 feet of depth. So if you figure the average depth of the western part of Lake Erie is 25 feet. So that means there's about 7 feet below there where algae are not photosynthesized.
Awesome. So now what do you have here for us, Mr. or Dr. Alford?
So, yeah, so this is another instrument that we teach kids about on our Lake Erie science cruise, and they get to use. So this is what's called a plankton tow net. And this particular one is used for sampling phytoplankton. Now, the phytoplankton are the green algae that we're interested in as the base of the food web. Not only are they the base of the food web, the phytoplankton also produce our oxygen. So this is a good statistic for everyone to think about. For every other breath you take, you should thank plankton, specifically phytoplankton, because it's phytoplankton that produces the bulk of the atmospheric oxygen that we breathe. So what we can do with this net is we can make what are called vertical tows. So I'm just going to drop this into the lake, and I'm going to pull it up, and it will be filtered into what's called this dolphin bucket. And so water will come out of there, but the plankton will stay in. And then we can dump this, what's in the bucket, into a sample jar, and then we can look at it under a microscope or some other instruments. So I'm going to show you how that's done. So it'll take a few seconds for it to get down. You may have a little air caught in it.
So Dr. Alford,
Hold
if
on, just
students did not have this particular sampling equipment, is there a way they could do something similar, perhaps in their own classrooms, or to get data to analyze in their classrooms from another source?
Well, yeah, I tell you what they can do. There are some kits that are available from some science supply stores, aquaculture kits, or what are called HAC is one company, a HAC test kit, where you can actually sample phosphorus and nitrogen that's in the water. And in some cases, you can sample chlorophyll. So chlorophyll is the pigment that the algae use to photosynthesize. Even if you can't get a net like this, you can take water samples in your lake or your river or your creek, and then see if there's chlorophyll in it just by doing a simple test. And that will give you sort of a surrogate measure of how much algae is in the water.
Okay, so now you're releasing the dolphin bottle, correct, from the net?
Yep. So you may see a bunch of floating blobs there. That would be green algae, and more than likely all of that stuff that is floating is microcystis, the cyanobacteria. Okay, now if we want to see what one of those looks like in a sample jar, we can show you that. While we're walking towards the sample jar that I have prepared for us, are there any other questions out there?
Absolutely. So from Mrs. Faldre, we have just some questions going back to what we discussed with the agricultural runoff. Or what are some of those non-point sources of contamination, which I believe you answered. But what can students do to help protect the watershed in addition? So if students were to work on a project in school, what are some things that they could do to answer or to help protect that?
Sure, yeah. We talked about phosphorus and nitrogen being the two most important sources of nutrient or fertilizer. So I'm holding in my hand a sample of plankton that I took this morning. You may be able to see not only the green blobs, which are microcystis, there may be some white ones swimming around. If you can see little white bodies, and I have a video of this, Dan, that we can show that shows the plankton more clearly. There's actually zooplankton and phytoplankton in here. So the zooplankton are the little animals that eat the phytoplankton. But this is what a clear water looks like unfiltered. So this is pretty mild in terms of algae, not very, not a very large biomass. But getting back to the nutrient issue, so phosphorus and nitrogen are the two primary components. Most of the phosphorus that runs off is bound to sediments. So if you have erosion from a creek or erosion from a ditch or a field, that phosphorus comes off in that sediment, goes down a ditch, gets into a river, comes to Lake Erie. Likewise, we can have what's called dissolved reactive phosphorus, which is readily available to algae. That can happen when in agricultural fields, if there's a lot of water and then it percolates into the soil, and as it percolates, it picks up phosphorus as it goes through the soil, and then it will end up into a clay tile system. And then that tile system acts like a little canal for that water to get off of the field. And there's usually dissolved reactive phosphorus in those tile systems that drain those agricultural fields. And so that's a primary source of phosphorus for the algae as well. Other sources of phosphorus and nutrients, like I said, come from raw sewage. So in communities where you have combined sewer outflows, where you have your sewage and your stormwater draining together, and if those get too out of hand and end up on the streets, it can directly impact the lake and your rivers that way. And getting into one of the ways people can help prevent phosphorus and nitrogen into lakes and rivers, one of the things I like the most is a rain barrel. If you can make a rain barrel to prevent water from running off of your landscape and into your road, try a rain barrel next to your house. Other ways are planting gardens that absorb a lot of the rain and keep soil from eroding off of your lawn or your garden. If you live out in a rural area and you live by a creek or some type of other flowing water body, planting trees, planting what we call riparian vegetation along the sides of creeks or even along the banks of small ponds in your neighborhood can help prevent phosphorus from entering into those waterways and getting into Lake Erie.
Thank you for answering those questions for us. We do have a couple of questions as we're moving up to the next area, I believe, where you're going to help to collect some macroinvertebrates. So these questions help to kind of model that. So for everyone at home, Dr. Alford is going to go up to a shoreline area, and he's going to take some samples of what we call macroinvertebrates that typically live in kind of high oxygenated areas within different water columns. And so it looks like he's going to get some materials here, and he's got some samples for us as well, perhaps sitting out.
Yeah.
So tell us a little bit about what we're seeing in front of us right now.
So this is one of the main instruments that students, when you come to Stone Lab and you come to one of our field trips, one of the field trips we offer is a benthic invertebrate walk. And what we do is we give students what's called a D-frame dip net. This is called a D-frame dip net because it looks like the letter D, and it's got a mesh net on the end. And what this is used for is for either scooping along the bottom if you have really sandy or soft sediment areas, or you can do what's called a kick set and disturb the bottom of the lake or the river with your foot and then scoop up invertebrates that way. So this is used by agencies all over to assess water quality, not just in Lake Erie, but in rivers and streams. And this bucket here, this is called a sieve bucket because it has this mesh bottom. So water flows through here, but anything I put in this bucket stays in the bucket. So what would happen is I will take a sample of the lake bottom, dump the sample into the bucket, water will flow out of the bucket, but what's in my sample will stay in the bucket. And then I can put it in a pan like this. So this is a sample I took this morning. And once you dump the bucket, maybe you could see some swimming critters in here. The things that are moving around are benthic macroinvertebrates. And the types, go ahead.
And why are studying macroinvertebrates an important indicator of water quality?
They are a very important indicator of water quality. And actually, when you do a science field trip with us, we teach how you can use benthic macroinvertebrates to score the water of Lake Erie as good, fair, or poor. Certain types of benthic macroinvertebrates are really tolerant of pollution, so they can do really well when things are bad. Some do just okay. And then there are some benthic invertebrates that are really intolerant of pollution. They don't really like it when there's low oxygen, or when there's a lot of sediment in the water, or when there's a lot of chemical toxicity in the water from some sort of chemical spill. So if we look at our sample and we have a lot of intolerant benthic macroinvertebrates, that means our water quality is excellent. Likewise, if we look at our benthic macroinvertebrate sample and we have the kinds of benthic macroinvertebrates that can stand a lot of pollution, that probably means our water quality is poor. But thankfully, we
Okay.
don't have that situation in Lake Erie. It tends to score, at least on when we do it with our kids, at least on the high end of fair. So,
Um, so I have another question for Ms. Faldray. Just a couple of quick ones. It sounds to me like the macroinvertebrates are indicating that the water quality is good and that we have a mild
mhm.
bloom at this point in the year. So is the water swimmable? As far as Lake Erie water is concerned, and if it is not, how would students know?
The water is swimmable. We do have a rule of thumb when people ask us about contacting water when there's a harmful algal bloom. About our rule of thumb is if it looks green, pea soupy green and really mucky, don't get in it. Um, don't let your pets in it as well. If people want to know how bad the bloom is at any one point, feel free to please go to there's a NOAA website, NOAA, the National Oceanic Atmospheric Administration. They have what's called the Great Lakes Environmental Research Laboratory, or GLERL. And if you were to search for GLERL and HABs maps, they will give you daily information on how bad the harmful algal bloom situation is in Lake Erie. So if it's pea soupy green, just try to stay out of it. And generally, the times of year that are the worst are August and September,
Okay.
sometimes in July, but for the most part, you feel free to swim in the water.
Oh, thank you. So this leads to a question from Mr. Stewart. He said that his students would like to know, in relation to different forms of pollution into the lake, so different runoffs into the lake, is there a variation of the levels across different areas of the lake? So is there an area of the lake in which the HABs or the harmful algal blooms
Mhm,
are the worst? And it
mhm.
sounds as though that they're also the worst potentially in August and September, just based
Yeah,
upon what you've just said.
yeah. So the most intense area for harmful algae, particularly the microcystis algae that we've been talking about today, is at the mouth of the Maumee River near Toledo. It's always going to be intense there in July, August, end of July, August, and in parts of September. The, Based on wind currents and other factors, it can go up towards Lake St. Clair, the northern part of Michigan. It can, from time to time, get as far as the Bass Islands here. There have been years where it's been thick out here. This year is a very mild year, though. And other parts of Lake Erie get no algal blooms at all. For example, most of the Central Basin, which is out by Cleveland, and then the Eastern Basin going towards Buffalo, rarely ever, if at all, get harmful algae or any that's in the case of blooms. That being said, they can suffer the effects of hypoxia when the blooms die, and they will stratify in the summertime and the wintertime if there's ice, which can have low levels of oxygen on the bottom of the water. And if a storm comes through, that low oxygen can bubble up and kill fish. That being said, most of the harmful algae is going to be in the Western Basin, particularly around the Toledo area.
Thank you. I think right now we're seeing a graph that has shown some incidences of higher levels of harmful algal blooms and how it's kind
Yeah.
of changed a bit from year to year. So what's interesting to me when I interpret this graph is that some years they're really high, and then
Yep.
sometimes the previous or following year they're very low. So when
Yeah.
we think back to some of the input of non-point sources that we've discussed, as well as point sources, we have some questions from several teachers that are concerned about how this flow is coming into the lake. And so I thought it might be a good idea to just talk a little bit about how farmers
Hmm.
input fertilizer onto their fields. And so my husband and I actually are also farmers, so I'm pretty knowledgeable about this. There is a series of practices called best management practices,
Hmm.
and there's also an incentive program through Ohio, currently right now called H2O Ohio. And so
Hmm.
farmers, to apply a fertilizer onto their crop, must be certified. So farmers do go through some regulatory processes and education classes before they're allowed to put any fertilizer out on their crops. But just as crops need fertilizer to grow, that same fertilizer, if it becomes mobilized and gets into the lake in the ways you described, can also allow algae to grow. So it is the
Hmm.
same. It is the same fertilizer from one area to another. So farmers are really trying to crack down and to do as much various rate fertilizer application. So that means to only put fertilizer on the field where it is needed at the time of growth, that the plant can actually pull that fertilizer in to help with the photosynthetic process. So there's right times of the year. They also are very knowledgeable about weather, so that they're not applying it in a time where it could easily be washed away, because fertilizer is very expensive. So there are several more best management practices, but I thought perhaps you could talk a little bit about how you kind of seen this trend come on in the last 20 years. And as we look at that chart there, how do you see it kind of go up and down? If there's some other information than just the best management practice use that has, also helped to change the bloom forecast for the future.
Yeah, so talking about that HABs forecast, that chart that may be in front of you. So you do bring up a good point that there can be really bad years on a scale of 1 to 10, where bad is 10. We have a few years like 2011, 2015, even more recently 2019, where it can get really bad. But if you'll notice, it can get really good again. So if good is what we consider a 3 or lower, it can get down to those levels within a year. And that's partly because Lake Erie can flush itself out. That's one of the encouraging things about our situation, is that it takes about 2.5 years for water to come into Lake Erie and then get flushed out to the Niagara River. So we can recover from one year to the next. And one year has no bearing on the other year. So if you have a good bloom one year, it has no bearing on the next year. Likewise, if you have a low bloom one year, has no bearing on the bloom size next year. But one thing farmers have been doing is following that 4R concept of putting fertilizer on in the right place, right time, right source, right amount. But one of the issues that we're dealing with over the past 20 years or so is how do we minimize the impact of what we call legacy phosphorus? So the phosphorus that's being applied today is not necessarily the only source of phosphorus that gets into the lake, but it's phosphorus that could have been laid down or applied 10, 20, 30 years ago that has made its way deep into the soil. And it's very hard to get that phosphorus out of the soil. But some ways that we are combating that, you mentioned the H2 Ohio program. That's Governor DeWine's state of Ohio led program. Part of that program goes towards building and reconstructing wetlands. Where we used to have wetlands, at one point got converted to agriculture. Now we're restoring some of these sites back to wetlands. And if you think of wetlands as kidneys, that's a good way to think of how wetlands function with respect to soaking up some of that phosphorus and nitrogen, making it into plant growth for wetlands instead of letting those phosphorus and nitrogen compounds go into Lake Erie. So that's another way that we're trying to combat the issue with phosphorus and nitrogen runoff, is wetland creation, but also working with farmers to get the right amount of nutrient, the right source of nutrient, and putting it into the right place near the roots instead of on the surface of the landscape where it can just get washed off again.
Thank you very much for that, Dr. Alford. I know we are starting to come up on the end of our time here with our virtual field trip, so I was curious if you would also mind giving us a little bit of a tour of some of the research equipment and facility there at the wet lab on South Bass Island. And
Sure.
maybe as you're moving in there, could you kind of come back to that invasive species question? I don't want to forget that question.
Yes. So
what are some of the big invasive species that we should be looking out for right now?
absolutely. So Kevin is showing you our wet lab facility and water quality lab facility. So this was actually an old federal fish hatchery back in the 1880s. The federal government used this to grow whitefish, among other species, and then stock them into the lake. As it turns out, the lake was actually really good at making its own fish. So Ohio State bought this as part of the lake laboratory. And so since about 1908, we've used this building for our research. And so what we're going into now is called our Flex Lab. And this is where we actually can analyze water samples for things like phosphorus and nitrogen containing compounds and also microcystis. So we're going to show you some of the equipment that we use. This machine right here, this is called a nutrient analyzer. And so what this does is it can take a sample of water from the lake and it will run through these tubes, and we can actually measure the concentration of phosphate and nitrate, nitrite, urea, ammonia. Those are nitrogen containing compounds. So we'll know exactly how much of those phosphorus and nitrogen fertilizers are actually getting into the lake. So we can do that with this machine here. And then over here, we have what's called a flow cam. So this machine right here will actually take dozens of pictures a second of a water sample, and using a camera and a computer, the computer will look at images of the water sample and actually identify for us if there's cyanobacteria in there. So we'll be able to know if microcystis is in our water sample just by running it through this machine here. And if we need to confirm our AI, if you will, we can actually use microscopes. So we'll actually take samples of water and look for algae under these microscopes here. So we have technicians that do that. So getting back to the invasive species question, one of the main, or two of the main, well, actually, there's over 180 aquatic invasive species in Lake Erie, which is a lot. We haven't had any new ones since the 90s or so. Zebra mussels and quagga mussels are still here. They're going to be here. They do not filter out microcystis algae. They actually filter out the good algae that our fish like, and they can bioaccumulate chemical contaminants in their tissue. So when they die, they can release those chemical contaminants if there are any. So we're concerned about those invasive species. Also the round goby, which came in with the zebra and quagga mussels from the Black and Caspian Sea, will actually eat our native smallmouth bass eggs. If the bass lays a nest, it can completely eat all that bass's eggs. Fortunately, we found out that the bass like to eat the round gobies, and our local Lake Erie water snakes like to eat them as well. So yeah, those are the two main ones that we are concerned about that are here still today.
Okay, well, thank you. We do have just another question or two, but in
Okay,
the interim, is it okay if we're going to show that mayfly video that you
sure, yeah.
that you gave to us? And can you talk a little bit about what we're seeing in that video right now?
Absolutely. So this is this is our mayfly ant farm, if you will. And so larval mayflies are very good indicators of good water quality. So mayflies will actually spend the bulk of their life for about 1 to 2 years as a little larva. And what you're seeing are its gills on its abdomen. It's in its little burrow and it's flapping its gills to bring a water current. And that water current will bring its oxygen and its food to it. And so it will live like that on the bottom of the lake for 1 to 2 years. And then it will emerge around June. And then every June we have that big emergence of mayflies that everybody around here is used to, where they can be kind of annoying and get on your car and your light posts and things like that. But that's a good indicator of water quality. If you're seeing lots of mayflies every year that are annoying to you and they get in your face, just consider that a sign that the water quality is good.
Good. So it sounds like mayflies are less tolerant of pollution than other
Yes,
macroinvertebrates.
yes, they
Is
are.
that
They're
correct?
less tolerant. They can't handle low oxygen environments or chemical pollutants.
Okay, perfect. Thank you. Well, Dr. Alfred, we really want to thank both you and your friend Kevin there for all of your help today and our quick tour of the Stone Laboratory. Students, if you have interest or teachers of coming up and learning more about water quality at Lake Erie, I know you can contact Dr. Alfred. We'll make sure that we follow up with his information and he can help you to see how you can come up and learn more about water quality with the scientists and the researchers up here at Stone Lab. Please remember to check out ohiocorneducation.org, where you'll find this virtual field trip as well as many others that we've had and that we will have in the future too. So thank you again for joining us, everybody. And thank you again, Dr. Alfred, for being our host today and allowing us to see a part of what you do.
Thank you, Heather. It's been a pleasure.
Yep, take care.